going to take a session on blockchains. I am Vinny VA, Director of Technology. So how many of you guys have heard about blockchains? How many of you heard about either of these? Sorry.
Yes.
Which one?
Bitcoin.
Oh, good job. Good job. Alright, so Bitcoin is what we call a cryptocurrency. It is a currency that exists only online. It is made by a guy called Satoshi Nakamoto. And the funniest thing is nobody knows who this guy is. Most probably this is an acronym, pen name kind of a thing that somebody made or a group of people made, because this is a very complicated and a very interesting technology. So right now, one Bitcoin is 1.5 lakhs. One Ethereum is 40,000 rupees. Now it's working. Cool. Before we start, I want to introduce you 4 people very important to cryptography. One is Alice, next is Bob, third is Charlie, and fourth is
Dave.
Dave. Alright. So these are the people that is used all over for examples in cryptography texts. Alright. So in this example, we are going to see some transactions between these people. Alright. So first we have a ledger. This will hold the account of all the transactions. So first A is giving B 20 bitcoins, from B 15 bitcoins to Charlie, and from there 5 more bitcoins to David. Alright. Now let's assume that Charlie is an evil dude. He is going to forge a transaction so that he can get more money. So how does the system not allow that? That we have to understand the concept of signature, digital signature. So right now, this is one of the most used things in cryptography. This is called the key pair. Everybody has a set of 2 keys. One is a public key and one is a private key. Public key you can give it to anybody, but private key you have to keep it with yourself. Alright, this is literally my public key. This is the public key that's there in our MAD server, so that I can log into it without using any passwords. And this is my private key. Obviously, I will not show you my private key, but for example, I have created a demo public key. This is what it looks like. Alright, so there is a software that makes this 2 keys. Why do we need 2 keys? Why not just 1 key? So the idea is, when you have to transfer the keys over a medium that you don't trust, you can't transfer a secure key over it. So private key I will never transfer over the internet or any other network. I will always keep it with myself. Public key I can transfer. So if somebody wants to give me a secret message, what they can do is take my public key, encrypt it using that public key, and only the private key will be able to decrypt it. So this is the basis of all encryptions, the modern encryptions these days. Alright, back to our example. So we can prevent this easily by making sure all the transactions are signed by their private keys. So if Alice gives money to me, Alice has to sign it. So every single transaction is signed like that. Next problem is with the ledger itself. This ledger is at one place. Suddenly the person who has the ledger can move things around. We don't want that. So we have several different formats to do it. One is the centralized ledger, the second is a decentralized ledger, and third is what Bitcoin uses a distributed ledger. Distributed ledger means everybody has a copy of the ledger at all times. They also has it. I don't know why it didn't. Oh, sorry. Bad animations. Cool. Now, if somebody makes a change, if Bob makes a change, everybody has to have the same ledger, otherwise it won't work. So when Bob makes a change, he will give that information everywhere, and there are some people called miners who collect this information and build a new block with it. Okay, we'll go into that, but before that we'll take a break and go into something called SHA-256. This is what we call a cryptographic hash algorithm, which means the hash algorithm is when you can give any message, there is an algorithm through which that message is run, and it will always output a string of 64 characters. There are other hash algorithms like MD5 or SHA-1, but this is what Bitcoin uses. So let's just some properties of a hash function. It should be very easy to compute. It should be very difficult to compute a text given a hash. So from the hash, it's almost impossible to find the original message, and unlikely that two different messages have the unlikely means practically impossible. Since these are like geeks talking, we won't use absolute terms. We will use terms like this, but it means practically impossible that two messages have the same hash. So any two messages, or the hash will be always unique. There will be one message, that means the hash will be always the same. Cool. So now we have the ledger. We'll go into the next part. The work of the miner is to find this one number. This one number is basically the ledger plus this number together hash should output a string that has the first X characters. For in this case, first 8 characters are 0. That's all they had to do. The problem is you can't get this number easily. You have to guess. You have to start at 1 and just go on till you find it. So there are a lot of miners all around the world just guessing these numbers so that they can get this. This is what we call a proof of work. So they are guessing till they get it. So they can, in this ledger, right now Bitcoin has around 1,000 to 2,400 transactions in one block. They'll put all this together into one block. And for that block to be officially in the system, it has to have a proof of work. So why do miners do it? There are companies, like huge companies, China has like a lot of them that just mines Bitcoins, just makes sure that these blocks are there. Why do they do it? Every time they do this, they add one more line to it. They say that this miner gets 12 Bitcoins. Right now, they get 12 Bitcoins, and that is a lot of money. And it's literally like winning a lottery, because a lot of people are trying to find the proof of work for the same block or something. Anybody who gets it first will get there added to the official chain. Cool. So this is what they call, basically the ledger, it's called a block. Let's see the different properties of the block. One, it should have the numbers. Next, it should have the proof of work, and very importantly, it will have, so there are other blocks. So this is what connects it. Every block's hash will be there in the next block. So when a new block gets added, it takes the hash of the previous block and put it in. Cool. And in this row, the very first block is called the genesis block. And from there, you can actually backtrack all the transactions that has been made so far. Cool. So mining reward. I already talked about mining reward. Right now, it's 12 Bitcoins. So that's actually generated out of thin air. That's how actually economy works. Right now, if bank gives you a loan, bank can actually give you way more, issue more loans than it has in its money it has in its possession. The governments have stipulated this, you can only give this much times the money you have, but banks can give. So whenever banks give out a loan, they are literally generating money. That's how Bitcoin mining also works. Whenever somebody is mining that, they are making money for themselves. But at the same time, there is a system to make sure that you can't do this forever. For example, in Bitcoin protocol, there is an average of 10 minutes to compute the proof of work for one block, to make sure that stays the same. And because of Moore's law states that the power of the processor doubles every X amount of time. I forgot the X. To make sure that is handled. So right now, you have to calculate the first 8 characters should be 0. After a while, the 9 characters also should be 0. Makes the complexity even higher. So next time that next character also should be 0 is around 2020, and that will half the reward. Basically, every time somebody calculates that proof of work, they will get only 6 Bitcoins as reward. And right now it's 12, and yeah, this is the number of this many blocks they make. next iteration will need more zeros in the calculation, and it takes 10 minutes on average. So because of that, there is a theoretical limit on bitcoins that can be made in entirety. That's 21 million bitcoins. So what will motivate the miners to work after this this is reached? So every time a block is created, every time a transaction is there, you have an option of saying, I can reward the miners this much, so that they will get priority to be included in the block that they are going to work on. So even after this limit is reached, that miners will get rewarded. Cool. All right, any questions? Yes, thank you.